In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light.
Today's lesson is going to be on cosmologies and the different ideas about thoughts on how the universe was created. Now you say, why is this important? Maybe it ain't important to you, but it's kind of important to me. So since I'm teaching the class, we're going to talk about it a couple of weeks. But I think it is important. I would dare say everyone in this room has a cosmology. Okay, you have a cosmology. Everyone has a cosmology. What is that? You've got a belief in how the earth was created, how the universe was created. Now, everyone in this room, I would also dare say, are creationists. At least I hope you are. You probably wouldn't be sitting in here. So your idea of cosmology is creation, a divine creator obviously implied in that, and certainly that's what the Bible teaches. But that's not what the majority of the earth believes, most likely. They don't believe that, and I think in the United States it's seem like more and more where people don't believe that. Or if they believe there's a creator, they believe in a different way that the universe was created than what I read about in my Bible. Okay, so that's where we're going to look. That's where we're going to look at this, and I do think it's important because when you're trying to refute someone, whether you be a young person going off to school or an older person studying with someone, and they start talking about the Big Bang, which is probably the most popular cosmology around today, especially of the non-believing, but even believers believe in the Big Bang. A vast majority of the what we would call believers believe in the Big Bang. They believe the Big Bang was created by God, and so they believe that. And so we need to, in my opinion, look at that. And is it true? Is it possible to be true? Could there be a way that would fit in the first book, the first chapter of Genesis? Maybe there is. So let's look at that and don't be afraid of it. What does the word cosmology mean? Well, cosmology comes from two Greek words, cosmos and logos, which technically mean world and word. So you wouldn't get necessarily the idea of talking about creation or how the universe came into being by looking at the root word. But logos can generally be generalized to mean the study of, and cosmos could generally be understood to mean the universe. So therefore, when you look at cosmology, it's the study of the universe. Sometimes you'll see the word cosmogony, and they'll be used interchangeably a lot of times because there's not much difference between them. In fact, I'm still trying to figure out what is the actual difference in the meaning. Well, the meaning means the study of the history of the universe. So isn't that kind of like the same thing? But you'll see those words used interchangeably. And so when he sees cosmogony, cosmology, there's not much difference between the two, but technically one is the study of it. So in ancient times, men had cosmologies. Of course, they had the Bible as well, but they had other beliefs as well. And one of that really were not Bible determined, but they were determined by man. Man reads the Bible, comes up with ideas what the first book of Genesis is talking about, but then had these other ideas of how the universe was constructed. Because as I said before, God used processes to create the universe, just like he used processes to create man. And we know about these processes looking back. We know now about the atomic theory and that sort of thing. Well, ancient men didn't have those theories, but they had some theories of their own. And two of the ancient cosmologies were that of a flat earth, which now we know you have to be pretty far out there not to believe in a round earth. But you know there still are flat earth people. Did you know that? There's people that still believe in the flat earth. You can go on Google and Google the Flat Earth Society people. They're still out there. I don't think anybody in this room believes that. Hopefully you don't, but it's pretty hard to refute the earth when you'd have to deny a lot of science, wouldn't you, to say that the earth is flat. And then the other cosmology that was out there was the fact that the earth was the center of the universe, and that the sun and the moon, well, the moon does, but the sun and the other planets rotated around the earth. Now, the flat earth was put to rest really by Christopher Columbus and then later Magellan when he sailed. What were people worried about when Columbus took off? That he was going to sail off the earth, going to fall off. Well, he didn't fall off, and he actually came back, and that was kind of proof that the earth was not flat. He went beyond the horizon and didn't fall off. Then you had this heliocentric cosmology, which again, the geocentric cosmology was the idea that the earth was the center. Then you have heliocentric cosmology, where it has the sun as the center of our solar system. with Mercury, Venus, Earth, Mars, Jupiter, so forth, revolving around the sun. Geocentric cosmology, that was put to rest by Copernicus and Galileo back in the 16th century. And so we know that that prevails now. We know that the sun does not rotate around the earth. But ancient man believed that, and not that many years ago, I guess, or centuries ago, was it disproved. Now they were considered, Galileo especially was considered a heretic for his view. You know, the Catholic Church did not want to hear anything about that, and he was ostracized and put in restricted movement in his home and couldn't leave because of that view. But now it's pretty well held. So I've lumped the four most popular cosmologies, I've lumped the cosmologies in four big groups. Now understand, there are many different cosmologies in the world. We're not going to have time. That would take years really to study if we did that. Certainly at least a year. We're not going to do that in this class. We're going to try to get through this in the next 2 weeks. So what we're looking at are the Western, I guess you could say, the Western cosmologies. You go to the East, and Africa and places like that. They'll have a different cosmology than what we're going to be studying about. But we really don't have time to do that. But I've put this in the more, I guess you would call it the more Western society, the more first world, more modern society. And these are the four that I consider the big groups. And then within each one of those groups, there's a lot of different ones. Even within the creation society or community, there's a lot of different theories on how the universe began and that kind of thing. So we're not going to be looking at everyone, but we're going to be looking at what I consider the four biggest groups, and I group them together. This is my grouping. This is what I've done. But I think it makes some sort of sense. And they can be placed into the naturalistic point of view. So naturalism, or from our other class, molecules to man cosmology. And that is, everything in the universe came about by absolutely natural processes. There was no intellect, there was no intelligence behind it at all. It's purely naturalistic. And that is one big group. The second big group would be the intelligent design community, which we've already studied quite extensively, and we'll study a little bit more. But the intelligent design community believes that there was intelligence behind it. Now, they don't necessarily believe in the creation of the Bible or what we read in the Bible. Some of them are, some of them aren't. Intelligent design community is a wide variety of beliefs as far as religion is concerned. There are Buddhists in the intelligent design community. There are Christians. There are Muslims. It's a wide variety. There's even agnostics. I don't understand that one, but supposedly there's agnostics in the intelligent design community, but it seems to kind of not to go that way. Then there's what I would call the old Earth creationism, old Earth creationism. And these are the people that believe in the gap theory, the progressive creationist, the framework hypothesis, theistic evolution. I would throw those all into the same category, and it really shouldn't be old Earth, should it? It should be old universe. They're called old Earth, but it's really more than Earth. It's the entire universe. And why do they have these theories? Because they look at the evidence, and from their point of view, the evidence points to an old universe. That's why we're going to spend some time looking at that, because I would say a large portion of the creation of the Christian community falls in this group. They are old Earth creationists. I was talking to a patient a few weeks ago in my office, and she's a pretty devout Baptist, but she believes in an old Earth. And then, of course, the fourth would be the biblical creation, or what we might term young Earth, but really not young Earth so much as young universe. And those are the four big groups. So, as we said, naturalism means everything in the universe, indeed the universe itself, came about by naturalistic causes. No creator intelligence was responsible for it. And where do they place the beginning of all this? Well, you've heard this term many times, and we've talked about it already, and that's called the Big Bang. But that's not the only naturalistic theory. There are other theories out there, because some scientists are looking at the Big Bang, and we talked about how the Big Bang has certain implications. It has an implication by its very nature of a beginning of something. And so because it has that, some scientists says, well, the universe has to be eternal, has to have been there from the beginning. And those are the ones that you would refer to as the steady state universe. So the Big Bang is not the only naturalistic theory. And there's even other permutations on the steady state universe. And then you have the Big Bang and the Big Crunch. In other words, there's this oscillating where there's a Big Bang going on now, but eventually there will be a Big Crunch, which means when the universe expands to its limits, and who would set those limits, I don't know. But whenever those limits were set, then there has to be a Big Crunch, and instead of expanding, it's contracting. And actually, even though Einstein was credited for maybe being the person that began this idea of the expansion of the universe, relativity doesn't predict an expanding universe. It predicts either an expanding universe or a contracting universe. And it just so happens the evidence looks like it's expanding right now. But it doesn't absolutely predict one or the other, but it predicts it has to be one of the two. But which one depends on the evidence. And most scientists now believe that the facts do support that there had to be a beginning of the universe, hence the Big Bang. And we throw up a few pictures here. These are the people that when you read your handout, if you haven't already read it, those names are mentioned in there. Einstein, Lemaitre, Gamow, and Hubble. They were sort of amongst a lot of people that behind the Big Bang, the theory was eventually developed. And of course, as I said, in Einstein's theory on general relativity, published in 1916, his equations predicted either a contracting or expanding universe, which that might seem, well, that's not such a big deal, but man hadn't thought of that before. Or if they thought about it, they didn't put it together like Einstein did. And again, note through his field equations. Then you had Edward Hubble. Everybody heard of Hubble because of why? Hubble telescope. It's named after him. He didn't invent it. You understand that. It hadn't been around that long because we're talking about 1929. But it was named after Hubble. Okay. So Hubble established that the velocities of the galaxies resulted from the general expansion of the universe, and he did this by Doppler studies, by looking at stars and looking at the color. You know what Doppler radar is, and you can look at color using Doppler, and because the changes in the color of the distant stars, he was able to deduce by the emissions that those stars were producing through their gas, through the helium and hydrogen in those stars, that they were moving away from us on Earth. And they were moving away from us on Earth. That implied that the universe was expanding. And then even before that, Abbé, Georges Lemaitre, an astrophysicist and Jesuit priest, promoted the concept of the Big Bang. Now, you've heard the Big Bang. The Big Bang was actually taken from Fred Hoyle. But Fred Hoyle was not a naturalist. He was actually a deist. We'll talk about that later when we get into some of these other ideas, what deism means. But he used it in a derisive term. He said, what do you think? The universe came about by some Big Bang? He was talking about it negatively. Someone latched onto that, and hence the name. So he gets credited with the name and a theory that he didn't believe in. But yet, that's where we got the name the Big Bang. Now, since that time, these fellows, and we didn't mention Gamow, he's mentioned in your handout. Other people that have looked at the evidences and looked at the relativity and so forth. And by the way, we looked at relativity, and nothing to be afraid of, but all experiments so far seem to support relativity theory, both general and special relativity. So they were starting to look at evidences, because that's what this class is about, isn't it? Evidences. So they want to look at evidences. Does the universe appear to be old? In 1964, Arno Penzias and Robert Wilson discovered 3K cosmic background radiation. What is 3K cosmic background radiation? At the moment of the Big Bang, physicists theorized that radiation would have been produced. That should be obvious. Radiation is energy. It's energy in the form of electromagnetic waves. That energy would have been produced, and that energy would still be around. And so they were looking for evidences of that energy. But they were able to show that the 3K cosmic background radiation, which seemed to give evidence of the Big Bang theory, and even won a Nobel Prize for it. So they discovered this radiation, this 3K cosmic background radiation. It's a real. We looked at electromagnetic waves last week, and you got the fast waves and the slow waves. These are real slow waves. Not when I say slow waves, that's not the right word. Real slow frequencies. The speed's the same of light, but the frequencies were real slow. And the only explanation from where this 3K background radiation could have been coming from was an event that occurred many, many years ago, and hence the Big Bang. So it was held as proof of the Big Bang. Then in 1992, astrophysicists from the United States reported findings from the Cosmic Background Explorer satellite. Once this background radiation was discovered, then by Panzias and Wilson, then there was other studies done, and they sent up a satellite to try to find this, and it was called the Cosmic Background Explorer satellite, and they confirmed this from outer space. And no matter which way this satellite was turned, the radiation came in from all directions. There was not one direction. It was picking up this radiation from every direction, which seemed to confirm again that something happened which emitted this energy billions of years ago. And once this was done, then it was kind of like when Darwin's evolution came out. Everybody started jumping on top of it, said, oh, we've got proof now. And all the other studies we looked at. So scientists describe the COBE findings, Cosmic Background Radiation Test, as the most exciting thing that happened in my life as a cosmologist. This comes from Carlos Frink of Britain-Durham University. Stephen Hawking's in his book. By the way, I should have said this to begin with, but for this class, I'm taking a lot of my stuff from Danny Faulkner's Universe by Design. Very good book if you can get it, put out by the Answers in Genesis people. Danny Faulkner is an astrophysicist, so he's got some credentials when he wrote this book. And then some of it will come from Stephen Hawking's A Brief History in Time. You've probably heard that book. Many people have this, very few people have read it, but it was a very, very popular book. And then some other things come from Hugh Ross, a creator in the cosmos. Now, we've talked about Hugh Ross in this class. He's a progressive creationist. And then finally, and this is a book I think was actually referred to me by Danny Cecil, Gerald Schroeder, Genesis and the Big Bang. Very good book, very good book. So might want to, if you really have an interest in this stuff, those are the four that I'm taking a lot of my information from for these particular classes. And from Stephen Hawking's, in his book, A Brief History of Time, he says that it was the discovery of the century, if not of all time. And then we have other superlatives. We have, it was considered the holy grail of cosmology by Michael Turner, astrophysicist with the University of Chicago, because now was quote unquote proof of a Big Bang. That's the way this scientist looked at this. This COBE satellite finding this low amplitude radiation, this cosmic background radiation, proved that the universe had a beginning. Well, I think it had a beginning too, don't you? So I don't know what that really proved, and we'll be talking about that later on, but still, there was a proof of something had a beginning, in their opinion, the Big Bang, because of the radiation left behind. So, according to Stephen Hawking, everybody know who Stephen Hawking is? Most people do. He's got ALS, Lou Gehrig's disease, and yet he has survived it, I think, for like 3 decades now. He's been around a long time. He has to speak with a machine, cannot speak with his own voice. Brilliant man, and he again wrote the Brief History in Time. But he states, and this is interesting. You say, well, what happened before the Big Bang? You know, ask a physicist what happened before the Big. What was around before the Big Bang occurred? The cop-out is, it can have no consequences and should not be part of a scientific model of the universe. In other words, we're not going to worry about that. We're just not even going to worry about it. If there was a Big Bang, it occurred, but what happened before that? There's no equations that can answer that question. You understand that? And he cops out, and so does everybody else when they look at this. So let's look at the Big Bang. And this is going to be very brief, but yet I do want to go into a little bit of detail, but try to keep it brief, because we need to study other things. But in the Big Bang model of cosmology, the Big Bang was the beginning of time. And with the beginning of the Big Bang, the universe was infinitely small and infinitely hot. I've heard the analogy of a mustard seed. Now, I don't think I've ever seen a mustard seed in my life. I've read about mustard seeds in the Bible, the grain of the mustard seed. Let's call it a sesame seed. I've seen a sesame seed. They put them on those little hamburgers, okay? Well, that's the size of the Big Bang when it exploded or when it occurred. Maybe we shouldn't use the word explosion, but when you hear the Big Bang, you think of the idea of an explosion. But it probably wasn't an explosion per se. But it was infinitely hot, infinitely dense, and infinite as far as matter in concentration is concerned. So it's infinitely dense, infinitely hot, and infinitely small. Basically almost nothing. But when it occurred, all the essential particles such as electrons, protons, neutrons, quarks, antiparticles, and positrons had their beginnings. And according to Big Bang theorists, this was literally in nanoseconds. I have that in your handout, but I think it was 10 to the minus 34 second. It may show up in another slide here, but that's quick. So in an instant like that, just like that, just in an instant, it's even quicker than that because that takes more than a nanosecond to do. Quicker than that, you had all the elemental particles produced instantly. Now these are not atoms yet. These are particles. You don't have protons and neutrons haven't come together yet. They're not forming atoms as we think of them. These are the particles: quarks, antiparticles, positrons. Any particle you can think of occurred at the beginning of the Big Bang. And again, the idea of infinitely hot, hotter than we would ever be able to measure, just infinite hot and infinitely small. So when this occurred, within 1 second after the Big Bang, the universe would begin to expand and would begin to cool down. And with expansion, you have cooling. If you have something that's infinitely hot and it starts expanding, you would expect it to start cooling. But it ain't cold. It's still 10 billion degrees Celsius at this point in the first second. Within 100 seconds after the Big Bang, it's cooling even more. And we're down to 1 billion degrees, which is the temperature that's inside stars, by the way. So it is beginning to cool. And because of this cooling effect, now the positrons, the electrons, the protons, neutrons would no longer have sufficient energy to overcome the attraction of the strong force. And we talked about the four forces in nature that we know about, and one of those is the strong force, and it also has a weak force, but these are all molecular forces. And because of that, then you started having an attraction of protons and neutrons and electrons together. And you would have the first the first atom produced when you do this. Well, what would that atom be? It would have to be hydrogen, yeah, because hydrogen has 1 proton, 1 neutron, 1 electron. So you have the beginning of hydrogen. And then hydrogen then would be the first atom constructed. What would be the second one? Probably helium, right? Helium is 2 protons, 2 neutrons, 2 electrons. What's going on in stars, bottom line, really is the production of helium. It's called nuclear fusion. Nuclear fusion produces a lot of energy, as you can imagine. We have nuclear fusion bombs trying to do that now, which the first atomic bombs were fission. They're trying to split the atom. Now it's fusing. You produce more energy by fusing than you do splitting, apparently. And that's what stars are made of. So stars are producing helium. And this would have been occurring very quickly on, as you can see here. So the early stage of the universe, which was extremely hot, produced significant radiation. And here's Gamow. And according to George Gamow, it produced radiation that would still be around today, hence the cosmic background radiation. And of course, this is the micro-radiation discovered by Penzias and Wilson that won them the Nobel Prize. And that's just a summary of the Big Bang. You don't have time to look at it right now, but you can see there how quickly all this occurred. It was 10 to the minus 43 seconds when all this occurred. So very, very, very quickly, the universe was created, according to the Big Bang theorists. There's a problem with the Big Bang, and they understood it really from the very beginning. And the problem was when you do the equations, and by the way, the equations and this was supposed to be kind of a uniform distribution. It's not haphazard. That's why the idea of explosion is probably not a good way of characterizing it. But it's supposed to be uniform. And there have been people that have tried to use equations to predict that. Those equations don't work. So this is hypothetical. There's obviously no proof of it. It's very hypothetical. And when you use mathematics to try to show it, it fails. So even the astrophysicist will tell you that some other reality had to be going on at the very, very beginning of the Big Bang, because certainly Newtonian equations don't work, relativity equations do work, but guess what? Neither does a quantum theory. Quantum mechanics doesn't work here either at the very beginning. Those equations just don't work. But the other big problem was that the hot Big Bang model does not allow enough time in the early universe for heat to have flowed from one origin to another. And this is according to Stephen Hawking. So, And he says in his book, A Brief History in Time, it would be very difficult to explain why the universe should have begun in just this way, except as the act of God who intended to create beings like us. Now, don't get carried away thinking that Stephen Hawking believes in the creator that you and I believe in. When he says God, he's talking about some sort of naturalism, not a supernatural force. At least that's what I have read. And even though when you read his book, you think, well, he believes in God. Maybe there's a sense that he does, but it's not the God of the Bible that you and I believe in. But there's again, this doesn't work. So MIT scientist Alan Goth suggested to try to solve this problem where there's not enough time for this universe distribution. He suggested that the universe may have gone through a period of very rapid expansion. And he termed this rapid expansion inflation. Now, the concept of inflation was purely invented to try to describe what was going on since the math didn't work. You understand that? There's no proof that inflation occurred, but it had to have occurred for the Big Bang to have occurred. And now everybody that's a Big Bang theorist believes in the concept of inflation. And so it is the only explanation we have at this time. And it's the only explanation, again, to present a smooth, uniform state of the universe, that it could have evolved from many different non-uniform initial states. And it's the only theory they have out there. But it's the one that's accepted. And this is kind of the idea of inflation. So within hours, talk about 100 seconds, now we're within a few hours of the Big Bang. I know this sounds kind of silly to be talking about seconds and then hours, but this is the theory. And they seem to think they have proof for it. Within a few hours, the production of helium and other elements would have stopped. And for millions, probably billions or so, basically nothing else would have happened. Nothing. You'd have hydrogen and helium, but you would have nothing else going on. And then during this time, the universe was expanding and cooling. And then eventually, it would have been slowed down by gravitational attraction. And that's when you would have had the galaxies form. So with the gravitational pull of matter, regions might start then rotating slightly, and then this begins the formation of mass and the formation of galaxies. And with the formation of galaxies came the formation of planets, from which eventually, through naturalistic forces, life occurred. Now don't be deceived. The Big Bang Theory is evolutionary theory. Okay? From the Big Bang eventually becomes evolution. It's a naturalistic explanation of the universe. Evolution is a naturalistic explanation of life. You can't really, it's hard to have both. Now, some of our progressive creationists and so forth try to put them together. I'll agree with that. And they try to put those two together, but they're really the same. They really flow from the same. They're both naturalistic theories. And most scientists who believe in the Big Bang are not creationists. So the universe then, according to the Big Bang, is 13.7 billion years old. Not 12, not 14, not 13.6, but 13.7. And the Earth was formed about 4.5 billion years old. So from the universe's point of view, the Earth is still very young. So what are the evidences for the Big Bang? First of all, do you have any questions on what the Big Bang, I know that's very quick, that's a summation, what the Big Bang is. You've heard about it before, but that's what it is. And so, are there evidences for a Big Bang? That's the first question. And the answer is yes. I'll answer that. I'll ask that question and answer it. Yes, there are evidences for it. And we're going to talk about them. Danny Faulkner, like I just told you, astrophysicist who is a creationist. He is a, if you want to use the word young Earth creationist, he's a young Earth creationist, young universe creationist. But he understands that there are evidences for it. And you can't just sweep the evidences under the floor and say, well, I'm not going to look at them. You're not looking at evidences if you do that, right? So let's look at them. And so there's basically three. One is the presence of the cosmic background radiation. Okay, the presence that it's there. Is it real? It's real. You can't deny that. They measured something and it's real. And that's probably the biggest hurdle to overcome as far as these evidences are concerned. But they're not the only evidences, but the cosmic background radiation is a hurdle to overcome if you're going to try to explain the universe being just thousands of years old instead of millions of years old. And that's probably one of the biggest ones. The other is evidence of an expanding universe. Now some have, again, began by saying there's all kind of cosmologies, and there are young earth creationists who say, well, there's really no evidence that the universe is expanding. They really have to deny a lot of science, though, to get to that point. They really do. And even Danny Faulkner, although he presents in his book the evidences that they give, their evidences are weak. They're really weak. The universe does appear to be expanding. Would that negate a creation event, though? I don't see how it would. But for the Big Bang theorist, that's part of their evidence. And so there is evidences of an expanding universe and the abundance of the light elements in the universe. What are light elements? Helium, hydrogen. The universe appears to be made of like 99.9% hydrogen and helium. That's an abundance, I'd say. And so there's an abundance of these light elements. So if the universe was created and the first elements formed were hydrogen and helium, and there's a whole lot of those still around, why do we have so much of that still? Well, that would be one of their evidences. By seeing that much light element, then we have evidences of an old universe, not a young one. Now, Faulkner says that a theory is best judged upon how well it explains data, but it should also have a predictive quality to it if you're looking at evidences. And so, are these three things both explanatory and predictive? The expansion of the universes is explanatory, but it's not predictive. Because I told you earlier on that Einstein's theories allow for a contraction of the universe just as well as they allow for an expansion of the universe. So they're explanatory, but you can't predict from his equations, from relativity, that the universe has to be expanding. It could be contracting, but the evidence is it's expanding. So there's evidence it's expanding, but that's not predictive of the theory. So general relativity suggests either an expanding or contracting universe, but it predicts neither. How about the light elements? Again, the light elements of the universe appear to be explanatory, but they wouldn't necessarily be predictive. Once again, you wouldn't necessarily predict that from the theory, the Big Bang theory. The fact that they're out there, they're out there. The universe is filled with mostly helium and hydrogen. So the Big Bang cosmology does not predict evidences or abundances of light elements, it does predict. The Big Bang cosmology does predict the abundance of light elements, but according to Dr. Faulkner, most people fail to realize that the information concerning the elemental abundances are input in creating the model. So they're an offshoot of the model. You come up with a model, now you see it, it predicts it. That's really not fair, is it? You came up with a model first. You came up with a Big Bang model, then you said, it predicts that. And again, of the three evidence of the Big Bang theory, the appearance of cosmic background radiation, according to Dr. Faulkner, is a clean prediction of the Big Bang model, and it's explanatory as well. CBR, cosmic background radiation, is real and has been confirmed many times, and denying its existence is not an option for a Christian. This is according to Dr. Faulkner, and I tend to agree with that. It's there, and just denying it, to deny it would be like denying the earth is round. You'd be in the flat earth people if you did that. I don't know if it'd be that dramatic or not, but it would be tantamount to that, sort of the same thing. But Dr. Faulkner points out that though many claim the COBE results perfectly matched predictions. COBE was that satellite that found the cosmic background radiation. He said that's not really true. Theorists have recalculated Big Bang models to produce cosmic background measurements, and this hardly constitutes a perfect match. And in this case, the data has guided the theory. But nonetheless, it's out there. But it's not a perfect match. It's a perfect match because they changed the equations to make it a perfect match. Some Christians have latched on then to the Big Bang model, and Dr. Hugh Ross was one of them. And he's written many books. He at one time has his own TV show. I assume he's still alive. Don't know that for a fact. I need to research that. But he was one of the biggest proponents of progressive creation, and he's a firm believer in the Big Bang model. And when you read his book that I pointed out, The Creator and the Cosmos, he offers proof, absolute proof from his point of view, that the Big Bang absolutely occurred. So to him, there's no doubt about it. And many other creationists that have different ideas have latched onto this too. And so they've attempted to use it as proof of a creator. And then they liken the Big Bang to the first verses in the book of Genesis. So when God created the heavens and the earth, that's the Big Bang. That's what it is. Kaboom. You got the creator causing the Big Bang. The Big Bang involves a singularity. You'll hear this word a lot amongst physicists. Singularity. Something singularly happened, one time and one time only, although there is the idea of contraction and expanding. And this singularity has a beginning, and of course, the beginning implies a creator according to progressive creationists. I would agree that a beginning implies a creator. I mean, it does. If the universe is not eternal, which I don't believe it is, and the Bible doesn't speak as if it is, then it does imply a creator. But it doesn't necessarily imply a Big Bang. But for you, Ross, this was a proof of a creator. And he goes to the Bible. He goes to the Bible. Job 9:8, Psalms 104, Isaiah, Jeremiah. I'm not going to turn to all those, but I do want to turn to Psalm 104. Job 9:8 talks about the constellations. Every one of these other verses is similar to Job 104. Psalm 104. Psalm 104 verse 2 says, covering thyself with slight as with a cloak, stretching out heaven like a tent curtain. And every one of those other verses, Isaiah 40:22, 42:5, 44:24, 45:12, 48:13, 51:12, every one of those verses in the book of Isaiah, you can turn to them after class, but they will talk about the same thing. It's the stretching out of the universe, stretching out. So to him, that is the expanding of the universe, hence the Big Bang. And Jeremiah and Zechariah, it's really the same thing. So this is his, quote, biblical proof that the Big Bang is mentioned in the Old Testament. But there's other problems with the Big Bang too. And there's a problem that Big Bang theorists now acknowledge. In the predicted age of the universe at 13.7 billion years and the predicted age of the earth at 4.5 billion years, there simply is not enough time, even in their own theoretical construct, for life to emerge. Now, when we talked last class, that was the reason I didn't get into young Earth, old Earth. Even if the universe is 13.7 billion years, there's still not enough time for life to have occurred spontaneously. And they acknowledge that, the ones that really look at it with an open eye. And with their theoretical construct, the Earth being 4.5 billion is still not enough time for life to occur. That's a problem with the Big Bang theory. But that's how old they say the universe is, not us. But if you look at the mathematic models, and we did that last class, that ain't enough time. So theories of expanding and contracting universe have now been offered to try to offset the time problem. It's kind of the multiverse universe that we looked at in last class. If there can be many, infinitely number of universes, then you've got enough time. And so physicists have no explanation for what occurred before the Big Bang or during the first 10 to the 43rd seconds of the Earth, or seconds of age. And this period of time is the topic of significant speculation amongst astrophysicists. And I would say, in Stephen Hawking, he doesn't spend much time with it. He just says we don't know and it's not worth even worrying about. And again, I mentioned this earlier, different quantum physics had to exist as conditions early or very early in the beginning of the universe cannot be explained by current relativity or quantum theory. And again, how does something come from nothing? And where did space-time come from? That violates the concept of causation. From U. Ross, I like some of the stuff U. Ross says. I don't throw everything out that he says, but he says there is no escape from a transcendent creation act, that's for sure. There's no escape of that. If one believes in the Big Bang, well, you don't have to believe in the Big Bang to believe that, but there's no escape. There's no difference from the creation statements of Hebrews 11:3 and Genesis 1:1, where the universe that we humans can detect is said to have been made from that which we humans have no possibility of detecting. And I'd say amen to that. If absolute nothingness spontaneously generates space-time, matter, and energy, the principle of cause and effect is violated, which further undermines the entire foundation of science, mathematics, and logic. Every other science except cosmology, we understand the concept of cause and effect. When something happens, it has a cause, and then there's an effect, and mathematics and science and logic follows that. Once again, Stephen Hawking says we just have to ignore that. So next week, we'll finish this up and we'll get into the other cosmologies. We'll try to finish that section next week.